Alright guys, I wanted to put this video together quickly just so you can understand how the sine and cosine graphs are derived and how they're related to the unit circle. So remember in one of the concept charts in 4.3 we talked about how the trig functions kind of related are related to the coordinate plane. So instead of saying sine equals opposite over hypotenuse, we can say that sine is equal to y over r. Instead of saying cosine is equal to adjacent over hypotenuse, we can say that cosine is equal to x over r. Alright? So we went over this. Oops. We went over this part here. And then since we're dealing with the unit circle here, our r is going to be 1. So really what we have is our x corresponding with the cosine of theta, and our y corresponding with the sine of theta. So we're going to use this fact to help us come up with this graphs for sine and cosine. Alright, so here, and again, you don't have to take notes. I just want you to watch this because I think if you just watch it, it becomes, it'll become evident on how these graphs are created. So along the x-axis here, notice that I have degree measures. All right, because when we graph y equals the sine of x, all right, what's my x? My x is really going to be theta. They're going to be angle measures. All right, so let's begin at 0. So y equals the sine of 0. So at 0 degrees, so at this point here, what's going to be what's the sine? So what's the sine of 0? Well, the sine is my y coordinate, so it's going to be 0. So I'm going to plot when x is 0, y is 0. Okay, now I go to pi over 6, so the sine of pi over 6, that's going to be 1/2. So I'm going to come here, pi over 6, go up a half, put a dot. Alright, my dots are going to be very tiny because it's tough with this app to kind of make dots. I kind of got to like tap to get it to hit, so bear with me. Right. So now we're going to go to the sine of pi over 3. Alright, notice how we skip over pi over 4 because I'm going every 30 degrees. I want the interval to be consistent. So the sine of pi over 3 is going to be 3 pi over 2. I'm sorry, the square root of 3 over 2. And what's the square root of 3 over 2? That's going to be 0.87. So here is pi over 3, go up 0.87, about right there. Alright, sine of pi over 2, bam, it's going to be 1. So right here, alright, the sine of 2 pi over 3 is square root of 3 over 2 again. Alright, the sine of 5 pi over 6 is going to be a half. The sine of oh, wait a minute. That was 5 pi over 6. Did I do that right? I'm a little off. So this should be 2 pi over 3 should be 0.87. 5 pi over 6. 5 pi over 6, that should be 1/2. Alright, and then pi is going to be, the sine of pi is going to be 0. 7 pi over 6, it's going to give me negative 1/2. So that's going to be somewhere right on 7 pi over 6. 4 pi over 3, the sine of 4 pi over 3 is negative square root of 3 over 2. So it's going to be about down here. Alright, the sine of 3 pi over 2, it's going to be negative 1. then I'm going back down to negative 0.87. Alright, that's going to be 5 pi over 3, 11 pi over 6, so we did that. 11 pi over 6 is going to be negative 1/2. This might be hidden again. And here. And then 2 pi is going to be back at 0. Alright, so connect the dots. Alright, and we have one period of the sine function. Alright, so if you wanted to get another period, you could go in the negative direction. Alright, so let me erase all of this good stuff. Alright, so and we're just going to do the, I think you guys got the idea, so we're just going to do the 5 basic points. So again, sine of 0 is 0, so that's already plotted. Alright, the sine of, where am I going? Okay, the sine of negative pi over 2. So negative pi over 2 is this right here, so it's really 3 pi over 2, so that's negative 1. Okay, negative pi is going to be 0. Alright, negative 3 pi over 2, that's going to put me back up at 1. And then negative 2 pi is going to be 0. Alright, so connect. Alright, and so there's what the graph of y equals the sine of x looks like. Alright, and so if you're making the sketch, obviously the points that you would want to make sure you had down was, okay, what's y at 0? What is y at pi over 2? What's y at pi, 3 pi over 2, and 2 pi? So 0, 1, 0, negative 1, and 0. So those are the kind of the 5 points that you would want to make sure that you plotted and connect the graph. Alright, so now let's do y equals the cosine of x. Alright, and so I'm just going to deal with those 5 points. 0, pi over 2, pi, 3 pi over 2, and 2 pi to make the graph of cosine of x. So the cosine of x, alright, whoops, the cosine of x represents my x coordinate here. So the cosine of 0 is going to be 1. So that's a difference. The cosine of 0 is 1 here. Alright, now I want the cosine of pi over 2. So that's going to be 0. The cosine of pi is going to be negative 1. Come on. Alright, the cosine of 3 pi over 2 is 0. And then the cosine of 2 pi is going to be back at 1. So you want to connect these. Alright. And then the negative angles, so negative pi over 2. Again, that's really 3 pi over 2, so that's going to be 0. Alright, negative pi is going to be negative 1. Negative 3 pi over 2 is going to be 0. And negative 2 pi is going to be 1. So connect these. Boom. Alright, so this right here, this right here is y equals cosine of x, and the sine of x is right here. Alright? So if you notice that the graphs are essentially the same, the only difference is that we take the cosine of x, if you shift it pi over 2 to the right, you're right on top of the function y equals sine of x. Alright, so hopefully this brings a little bit of clarity on how the sine and the cosine functions are derived using the unit circle.